Assalamualaikum, we are from Group 3 and today we will be presenting our engineering mathematics discussion for topic 2. The question we choose to discuss is question 7. First of all, we would like to thank Madam Rose Sagijan Binti Farikan for her guidance. Hello, my name is Nufasha Syahira binti Zuhari. Now matrix 07 DKA 25F1034. Before we start, I will introduce the member of our group. I will begin with the introduction. Then Florencia will explain the conclusion step. Shada will present the conclusion. And finally, Shafika will explain the diagram. Now, let's start with the introduction. Introduction. In calculus, differentiation is a fundamental concept as to make sure the rate of change of a function with respect to a variable. One important application of differentiation is an identify stationary point on a curve. A stationary point occurs when the first derivative of a function dy dx is equal to 0. At this point, the gradient of the curve is 0, meaning the tangent line is horizontal. Stationary point can be classified into three main types: maximum point, minimum point, and point of inflection. To determine the nature of a stationary point, we ask the second derivative test. If the second derivative is negative, the point is a maximum. If it is a positive, the point is minimum. If the second derivative is 0, the point might be a point of inflection. Understanding stationary point is important because they help us analyze the behavior of graph and solve real-world problems involving optimization, such as maximizing profit or minimizing costs. Learning target. Students will learn how to complete derivative as basic rules such as the power rules, product rules, quotient rules, and change rules.
Hello, my name is Shafika. Number matrix 07 DKA 25F1046. First of all, let me explain what a theorem means in this question. A theorem is a graphical representation of a function that helps us visualize how the function behaves. By using a graph, we can clearly see turning points, the direction of curve, and the location of stationary point. To sketch this graph, we selected several values of which are negative 1, 4/3, 5/3, and 0. We substitute this value into the function to obtain the corresponding y values, then plot the points and join them smoothly. From the diagram, we can observe that the curve first increases, then decreases, and finally increases again. This means the graph has both a local maximum and local minimum. In terms of shape, we can describe the curve as both smiling and sad. The path shaped like an upside down curve, which looks like a sad face, represents the local maximum at the point 0, 0. Meanwhile, the upward curve that looks like a smile represents the local minimum at 4/3 and negative 64/27. So, the theorem confirms our calculated result and help us clearly visualize the behavior and shape of the function. Next, my group member will explain the calculation step.
Hello, my name is Florencia binti Saleh and my matrix number is 07 DKA 25F1076. I will take question C, which is solution for the given problem, which is y equals to 2x with the power of 3 minus 4x with the power of 2. So step 1 is find the value of x. We solve in dy per dx first, and in the end we got 6x with the power of 2 minus 8x. Then we solve that expression with EQN on calculator. In the end we got x1 equals to 4 over 3, x2 equal to 0. Then step 2 is find the value of y. We insert the value of x we got from the EQN into the first expression given in the problem. So when we do that, we got negative 64 over 27 and 0. Next is step 3, state the stationary point. We just insert the value of x1, y1 and x2 and y2. Step 4 is determine their nature, where we get the expression from dy per dx, 6x with the power of 2 minus 8x into d with the power of 2y per dx with the power of 2. Then we got 12x. Then the value of x1 and x2, we insert it inside 12x to get the minimum point and maximum point, which is for x1 we got the minimum point, which is 16, and maximum point for x2 is 0. So at last is step 5, sketching the graph. First thing first, we make the schedule, inserting maximum point and minimum point we got from the step 3. Then we take another value for xy to complete the schedule. From the picture, we can see how the graph look like for this given problem.
In conclusion, engineers use differentiation to calculate speed, acceleration, and change in force or stress. It is also used to find maximum and minimum values, such as the strongest design or the most efficient use of materials. In engineering fields like civil, mechanical, and electrical engineering, differentiation helps engineers design safer structure and better system. Therefore, differentiation is an important tool that helps engineers solve real-life problems.